Chris Chinnock here for Insight Media. I'm in the iZone at DisplayWeek 24 with a company called Panamorph. So what Panamorph has done is modify or create a new optical design for VR headsets. For example, if you have a MetaQuest 3 headset, which is what this demo is going to be based on, it's an LCD-based solution. It has a backlight that is edge lit. And that light fills the LCD panel, goes through the pancake lens, and also floods all around the eye, not just the pupil of the eye. It floods all around the eye to create a nice eye box. That's great, but the consequence of this whole architecture, and this is generic, is by filling that LCD panel with the light from the backlight, you create a lot of scatter, and that scatter reduces the contrast. And so you can improve the contrast if you want to go to a micro OLED, for example, but that's a much more expensive solution. So if you want to stay with an LCD solution in pancake lens here, you should consider this solution here they call Exit Pupil Modulation. So what they've done here is modify this MetaQuest 3 optic. This is the pancake lens directly out of a MetaQuest 3. All this part back here is the modification. And like I said before, the normal one has an edge-lit backlight. This is now a direct backlight. So here is the modified direct backlight, which is what sits on top of the optic right here. This just has a printed microlens array on top of it, and it has a fold mirror to bring that light down through the pancake lens and at focus where the exit pupil is of pancake lens. So what's happening here is this is actually a second imaging system. You've got two imaging systems going on here. You're actually imaging the backlight through the pancake lens at the exit pupil, and at the same time, you're also forming an image of the LCD panel at the exit pupil as well. That sounds a little strange because it kind of is. It's a new concept. But the advantage here is that each one of these LEDs, because it has a little bit of space here, each one of these LEDs is designed to fill the whole panel behind this pancake lens and fill the exit pupil. But this is kind of now let's call it a direct, it's kind of like a direct backlight in a normal LCD panel. But when you do direct dimming, local dimming in an LCD panel, when you do that, you are turning on LEDs at various luminance levels, but that whole panel is being illuminated by those LEDs, and so you're modulating the light in a different way. What you're doing with this one is you're actually modulating the exit pupil light from this backlight. So in the demo, what they do is when you first there's like 4 images in the demo. So in the first image, there's some calibration rings to get yourself positioned in the exit pupil, and they put all those LED lights on for the second image, which simulates exactly the way the MetaQuest 3 is designed today. It's filling that whole LCD panel and filling the whole exit pupil, and filling light all around your eyes with a lower contrast and blah, blah, blah. In the second part, then, they only use 4 LEDs. Those 4 LEDs fill the whole panel, but now are only part of the exit pupil is filled. And what you see is they can now turn up the power for those 4 LEDs, but the image quality, the image luminance to the eye remains about the same, but the contrast goes up because you've reduced all that stray light, because you've reduced the size of the exit pupil. And now the power has gone down to only 15% of what it was when all of those LEDs were illuminated. Then the fourth image then is when they go to actually one LED. Again, that one LED can fill the whole LCD panel with light, but now it goes down to 10% of the power when all those were on. There is a trade-off. The trade-off is the exit pupil gets smaller as you reduce the number of LEDs. So it becomes a little bit harder to find the sweet spot to find that image. That may or may not be an issue depending on your design. But if you have eye tracking, then that's problem solvable. You can keep moving that exit pupil to track the eye. So that is most of the benefit I see here: lower power, higher contrast, the ability to use LCD panels to be able to produce a lower cost headset, and a very new and unique concept here: exit pupil modulation. So that's the story. Chris Chinnock here for Insight Media.